Welcome to LNP Renewable System Limited. Today we are going to discuss some of the basics of electrical technologies, part 25. So we had classified the session into 25 parts. If you have missed out other parts, no issue. Please subscribe to our channel. In our channel, we had created a playlist. So by going into the playlist, you can able to learn all the 25 parts which being discussed regarding only dedicated to electric vehicles. So in our discussions, we might be using so many abbreviations in the short forms. If you have any doubts, kindly refer to these parts. So what are the things that we are going to discuss? Most importantly, we need to know how we are making a control in brushless DC motor using the Hall sensor, and what are the different control strategies and its advantage, how a vector control is done in electric vehicle motors. Okay, and most importantly, for batteries also we have a standard, that is automobile industrial standards 48, and for crash safety requirements, what will be the crash safety requirement for electric vehicle, and how a powertrain sizing is done. So when we see here this Hall sensor, we have a Hall sensor, 3 Hall sensors for positioning the 3 different positions. Okay, we can classify it to 12 different zones. Okay, but only thing is that if the sensor A is 1, it means it is 100. So the phase B is available. Okay, phase B will be available for it to operate. Okay, and if sensor E and B SE got detected, then phase B and C will be available. Okay, so based on it, different sort of movements will be created in a brushless DC motor. Say for example, if the Hall sensor C receives an input, then it means that there won't be availability of phase B. So phase A will be given for positive and phase C will be given for negative. Even though it has 3 phases, all the 3 phases will not be given at the same time. Based on the Hall sensor positions, it will be provided. So here, this is an example how it works. So when we sort out the computation strategies, we can either do trapezoidal control or sinusoidal because wherever the trapezoidal waveform is getting created, there we can go for 6-step trapezoidal control, or where the sinusoidal waveform is getting created, then there we can go for sinusoidal control. Okay, but in trapezoidal control, the angle difference will be around 120 degree, but for sinusoidal it will be around 180 degrees. Okay, and for trapezoidal the algorithm is very much simple, but for sinusoidal it is little complicated. Okay, for a lower end application we can go for this trapezoidal control, but for the higher end we can go for sinusoidal. Okay, and but for trapezoidal control we have a torque ripple issue. Okay, and also it has a limited performance. But for sinusoidal we have a good performance, but only thing is that it should have a lower maximum speed capability. Okay, and it is easy to implement field control, and we can reduce the noise in the sinusoidal. So what is FOC? That is field oriented control. It is the best efficient method to increase efficiency for the transient operations, and it is a very responsive speed control for different loads. Here we are performing this field oriented control for the induction motors. In order to control it, we are using the direct DC power supply. We are converting the DC power supply to AC for controlling the induction motors. Apart from it, we have different switching states to control the inverters to provide the required outputs. Okay, and most importantly, in the field oriented, we have a decoupled control of both electromagnetic torque and the flux. And acoustical noise reduction we can do using the sinusoidal waveforms. And we have active electrical brakes and energy reversal methods for the field oriented control. So when you go for a vector control on an electric vehicle, first thing is that we need to know the demand torque calculation. So this demand torque calculation will come only from the brake, from the accelerator. Okay, and if there is a reduction of demand, then by pressing the brake pedal we can reduce the acceleration, and most importantly we will have a vehicle speed and we have a DC link voltage. So we need 4 parameters for calculating the demand torque calculation. After that, when we create the final torque output, okay, we are classifying into different quadrants for the easy calculation. Okay, and apart from it, we are going to perform the PID control loop, which is an advanced controller. In that one, we have 2 transformations happening. One is 2 inverse transformations are happening and 2 forward transformations are happening. So in the inverse transmissions, what is happening? DC will be converted to AC, again AC will be converted to 3-phase AC. Okay, whereas in case of forward transmission, what is happening here? DC will be converted to 2-phase orthogonal AC, and those 2-phase orthogonal AC will be converted to 3-phase AC, which will be provided for to run the induction motor. We have pulse width modulation and inverters also for the better running of the induction motors. So from the 3-phase change to a stationary, we are using the Clark method, and with the help of the PART method, what we are going to do, we are converting a rotating to a stationary one. Next, we have an independent control for flux and the torque. Next, again after the making the forward transformation of using the PART method, again with the help of a PART inverse method, we are doing the inverse transformations, and at last we are doing the space vector modulation, and we are getting a 3-phase output to control the induction motors. So this is how vector control is happening in an electrical vehicle. So even though there is a rotating frame, you are in a stationary frame, it is very difficult to monitor. But when we are into the rotating frame, it is easy to focus a particular object. So as we told earlier, so our supply will be in the 3-phase. We are converting the 3-phase into a stationary one using the Clark method. Again with the PART method, we are converting the rotating to a stationary one, and with the help in the controlling process, that is DQ controllers, we are making an independent control of flux and the torque. Again what we are doing, we are making a stationary to rotating, and again we are doing the space vector modulation. So we will get all the 3 phases for controlling the induction motors. So what will happen in an electric motor? Okay, flux weakening sometimes will happen. Okay, so when it will happen? So it will happen when the terminal reaches the rated voltage. That is most importantly the permanent magnet synchronous motor flux weakening control we are using for mainly for the electric motors. Okay. And apart from it, in order to reduce the torque, okay, we need to increase the speed, which will leading to keep the power constant, which is a constant power operation. So when we go for a computation strategies, we have 3 computation methods. One is trapezoidal method, sinusoidal method, and field oriented control. In all the 3 controls, we can do excellent speed control. But when you get into the torque control, we can classify the torque control into 2 categories. One is a low speed and the other one is high speed. In the trapezoidal method, torque ripple will be happening for the low speed, so we won't use the trapezoidal for low speed applications. Okay, and most importantly, to get the feedback, we are using the Hall sensors for the trapezoidal method. Whereas in case of sinusoidal, low speed is possible, so it is excellent for low speed. For high speed, it is inefficient, so we won't use the sinusoidal method for high speed control, torque control. Whereas the field oriented control, we can either do low speed as well as high speed. It is excellent for both torque control of low speed as well as high speed. But in the sinusoidal, we can use encoders and resolvers to get the proper feedback of the exact positioning. Okay. Whereas in case of field oriented control, we are using the current sensors and the encoders. Okay. But most important thing is that the algorithm for a trapezoidal computation is very low, whereas sinusoidal will be medium, and for the field oriented control it is very high. For even for the batteries, okay, traction batteries, we need to get the certification AS048 standard. Okay, so according to the standard, the batteries will be undergone short circuit test, overcharge test, even shock test. They will try to provide. They will try to provide 10 shocks, which is a half sine wave with 30 gram amplitude of for 15 milliseconds duration. Okay, and even vibration tests also they will do for these batteries. They will create a sinusoidal vibration, okay, with the frequency of 30 to 150 hertz, and they will try to do the sweep rate test, and they will try to do this test for 2 hours per axis. Okay, and even they will do the nail penetration test also for the batteries up to 8 centimeter per second. Okay, so what is the pass criteria in order to get a AS048 standard approval for your battery is that there should not be any physical damages when we are doing any sort of this test, and there should not be any melting of components, and there should not be any fire or explosion. If this happens, then the battery got passed and AS048 standard will be provided for your batteries. Apart from it, there are so many standards, that is mechanical abuse test, thermal test, and electrical abuse test also. So the same test which we had already discussed, the AS156 standards. So when we get into the BMS functionality, it should protect against the external short circuit. It should protect against over voltage and over discharge, over temperature, even over current protection also it should provide. So when we get into the crash safety requirement of electric vehicle and hybrid electric vehicle, first thing is that lateral collision, that is AIS099, and frontal crash, that is AIS098, and rear end crash ECE R32. And is there any electronic spillage or electric shock protection, then it should comply FMVSS 305 standards. So this is an example of a crash requirement. Okay, by giving a high voltage line, if you try to create a crash, most importantly the airbag should come. Okay, and if you want to do the practical calculation for a powertrain sizing, first thing is that try to consider your vehicle is moving in uphill. So when it is moving in uphill, all these parameters you need to get into consideration, because what is the acceleration due to gravity, we need to know at what force it is moving upward. Okay, and what will be the change of grade. Okay, and most importantly, in order to calculate the sufficient power for the different load conditions, we need to know the aerodynamic drag, we need to know the rolling resistance, and we need to know the change of grade, and we need to know the acceleration requirements, and we also need to know the losses in the mechanical gearings and bearing frictions when we are doing the mechanical drivetrain. So in the rolling resistance, we can use this formula, PR is equal to FR into velocity. The FR is nothing but the rolling resistance of force in newtons. Whereas in order to calculate the FR, we need mass, gravity, and mu r is nothing but the coefficient of rolling friction for two surfaces. So this rolling resistance coefficient are fixed. If you are going for a car tire on a concrete, its rolling resistance is 0.013. If you are going for a gravel road, it will be 0.02. If you are going for a tar road, it will be 0.025. And if you are going for an unpaved road, it will be 0.05. If you are going for a field condition road, it will be for 0.1 to 0.35. And if you are running your vehicle on iron rails, then the rolling resistance will be from 0.001 to 0.002. So first and foremost thing is that we need to know the calculation to convert our values into meters by seeing the things that has been mentioned in our tires, because 195 bar 55 R16, it means the width of the tire is 195 millimeters, and 55% here describes the aspect ratio which represents the height of the tire sidewall. Okay, and R16 here refers to the diameter of the inner area of a tire. Okay, it will be in inches. Then we need to calculate everything into meters for our required calculations. And for the aerodynamic drag coefficient, based on the vehicle type, the coefficient is going to be different. If it is open convertible, then the value is different. If it is a van type, then the aerodynamic resistance is different. Okay, if it is a normal ponton type, the coefficient of error resistance is different. So you can refer these tables for preparation when you're making any sort of calculations. Apart from it, we need to know the gradient degree. It should be in degrees or it should be in the percentage. In order to calculate the slope in degrees, then you can use these formulas for your better calculations. Apart from it, we need to know the total resistance. Once we calculate rolling resistance, aerodynamic resistance, gradient resistance, acceleration resistance, we can calculate the total resistance so that it is subject to change with reference to the various driving conditions. Thank you so much. Please subscribe and press the bell icon and please share. So if you want to know more and learn more, you can contact us. We can provide the contact details here. We LNP Renewable System Integrator, we are providing design, installation, testing, commissioning, consultant supports for solar on-grid, off-grid and hybrid applications. And if you are really interested to know the electrical basics, then you can contact us. We are also providing PLC programming training for Siemens Android Delta PLCs along with the certification ISO 9000 2018. So you can contact us. Apart from it, if you are really interested to work in the GCC countries, you want to learn regarding the building management system and building automation control system, then you can contact us. We can provide the contact details here. So this session will be going to be an enjoyable session because this is the end of the session. So we had discussed more than 25 parts regarding the electrical vehicle technologies. If you missed out anything, no issue. Please subscribe to our channel and please share to the maximum people. In our channel, we had created a playlist. By getting into the playlist, you can able to watch all the 25 parts we can discuss regarding the electrical vehicle technology. Thank you so much.